Science is fraught with biases. And today we're going to talk about the streetlight effect. The streetlight effect is really cognitive bias. And what I mean by that is we tend to start all of our searches from things that we know. So we're biased toward what we already know. It makes sense. You feel most comfortable, and then you try to branch out. And there's reasons for this. So papers don't get published if you can't ground it in what is presently known. It's rare that a paper comes along and can be totally put forward like Einstein did with like two references or something crazy like that. But rarely do you see that kind of thing. Anyways, so in this video we're going to talk about the streetlight effect, the cognitive bias of science, and how do we get around it. And ultimately, what we're trying to do is find methodologies to get over the knowledge gap. But first, you've got to identify what is the knowledge gap. And that part ain't easy. Methodologies maybe you can put forward, but first you got to figure out what the heck is out there that you don't know that you're trying to figure out. Anyways, so the streetlight effect is cognitive bias. Let's take a look.
The JIRA Foundation presents this series called Navigating Research.
Science, okay, it's a great way to say it. Science is limited to the biases we live in, all right? And not just the biases, really it's what we don't know. And if we don't know something, we tend to go towards what we do know, ergo bias, okay? We know something, so we start from there. That's the idea of this thing. So a known unknown is where most scientists sit. They will like to believe that they start from unknown unknowns, but I doubt that's the case. Most of us, we start from what we do know and we look for something we don't know. And I've always quoted to people many times that I'm always looking for something I'll never find, and if I do, I won't understand it. And that really sums up an unknown unknown. Okay? So, and this cartoon strip right here is a perfect example of this. They call it the streetlight effect. So some guys drop something and he's looking for it. A policeman comes along and says, "Did you drop something? Is it here?" And the guy says, no, I dropped it a couple blocks down the road. And the policeman asks quizzically, "Well, why are you looking here?" And the man says, "Well, because there's better lighting." And that really synopsizes science, really. We start from what we know. We sit around, we under a light post where we know certain laws of nature. We start from there. And that's what this video will be about. The known knowns, the known unknowns, and the unknown unknowns. There are 4 permutations of known and unknown, and you see them here. The known knowns, known unknowns, unknown knowns, unknown unknowns. All of which have methodologies with which we can work with them. So you have the known knowns, as you can see here, it says analogies, lateral thinking. Known unknowns, basically all of science. We write a hypothesis, we create a hypothesis, we hypothesize, then we measure, iterate, and then modify our hypothesis and carry on. And then, of course, in the business world, they generally know what they want, but they don't know how to do it, so they brainstorm and things like this. And, of course, finally, we have the unknown unknowns, where we all want to be. The unknown unknowns are on the other side of the knowledge gap. And they become unknowns because, one, we cannot define what the knowledge gap is, nor its depth of knowledge that we miss, or what the problem itself is. And therefore, it's a knowledge gap. We really come to a cliff. So we work from known unknowns, and we push it as far as we can until we get to the precipice of a cliff, below which we don't know the depth and the breadth to the other side. We don't know. And that becomes the world of unknown unknowns. And this is where we're sitting about. And I'm talking in riddles, obviously, because I don't know what is on the other side. I just don't know. And that's what we strive for. Here's a great little quote by Donald Rumsfeld. I can't remember the number, but he was the Secretary of Defense in the George W. Bush administration in the United States. He was a very difficult person to work with, at least that's how he's described, largely because he liked to argue, and he expected you to be able to defend your position. You can't just give him an analysis and not defend it. And this is the kind of things that he thought about, the unknown unknowns. And you could imagine, in the world of the military, this is all important. You want to know who your enemy is, their capabilities, and how are you going to defend against it. And so an unknown unknown in this case is, I don't know who the enemy is, and I don't know what methodology they're going to use, and I have no knowledge of how I would defend if I did. Here's a great little analytic I found on the internet. Can't remember what source. And effectively, cognitive bias is we start all of our work from known knowns. What we have read, what we've written, our experiences, our experimentation, all of that stuff are known knowns to us. And that's our bias. And it's natural to start there. But we want to find a way to get to unknown unknowns. And here they've made a really cool suggestion. Machine learning, artificial intelligence on big data. So what you're basically saying is, you look at the entire sky. I'm an astronomer. You look at the entire sky at all wavelengths, in both spectroscopic and continuum mode, and you're monitoring all the time. And then you want to look for things. Just look for things. So you start teaching the computer to look for particular types of objects, and then it goes and finds them in patterns inside the data sets. And that would be a great tool to get over the knowledge gap. First off, to identify that there is a knowledge gap, that there is unknown on the other side, and then how to get over it. This is a great little tool. In the end, all we're trying to do is get across the knowledge gap. And at no time, by the way, will you have another person on the other side saying, I know, so they could teach you. So if there was somebody on the opposite side of the knowledge gap, which is called a professor, they will tell you, here are the problems we want you to solve. And here's the methodologies to use for you to get across this particular gap. But in research, you're actually at the edge of a precipice. There's a cloud, there's a fog between you and the other side, and there's no knowing what's there. And there's no knowing how deep it is. So in order to be successful, first and foremost, to get observing time, that is, in this case, or for people to take you seriously when you write papers, you have to ground everything you do in the known knowns. In other words, you have to bias yourself. But when you do your actual research, everything you're doing outside of writing the paper or the proposals, use DOTI, diversity of thought and imagination. Try to get over this gap in your head somehow. Try to find a way to do it. You know, machine learning, artificial intelligence, wonderful, great tools. If you already have data sets, such as a virtual observatory or somebody else's data set, they exist. You ask permission, you apply the data, your machine learning to it, you find things, and that's all publishable. That'll help you to be successful. But DOTI helps you to find things that nobody else has thought of, nobody's observed. Okay? So basically, you've got to find ways to be serendipitous and stuff like that. You do that by being imaginative and really thinking outside of the box. There is no box. I've said that in many videos. There is no box. And here we stand at the edge of a cliff. We don't know how deep it is. We don't know how far across it is. We have no idea what is on the other side, even if we knew there was another side. And how do we get there? No one can tell us. There's no professor standing behind you saying, that's right, that's the question to ask. There ain't that. It's you. So you got to use your imagination. You got to find it. You got to look out there and see and say, hey, this is new, this is interesting. Or come up with something. And then root it in your cognitive bias. What you know, what everybody else knows. And you'll be much more successful. And you might get across that gap. So, try your luck. See if you can jump over. If you're one of the crazy ones that just takes a flying leap without being able to see, well, I'll tell you something. The landings can be pretty sore.
Thermodynamics of Moving Bodies by Albert Einstein. His fourth paper. This year. I haven't seen anything like this since Newton's Annus Mirabilis. Dr. Lauer, are you honestly comparing Einstein to Sir Isaac Newton? Read it. He provides no footnotes. That's because he has answered a question no one was asking.
Einstein came up with a solution to a problem nobody was asking the question for. And isn't that the definition of an unknown? Now, I don't think this was an unknown because there was physics around. The real beauty of Albert Einstein was, unlike this guy who is just looking at everything from the observer's perspective, Einstein actually looked at both perspectives, the observer and the observed. And as a result, he said to himself, hey, the physics has to be the same from both perspectives. And if it isn't, we got a problem. And that's what he solved. Okay? That's really what he did. Now, I will say this. Cognitive bias, the streetlight effect, not bad to start. All your research can start from this because it gives you literally a starting point. Hey, funny. You know, what's the brilliance of that? Every sentence starts with a letter, right? You know, a word. And the same is true in science. So all I'm saying is cognitive bias isn't bad. Just don't get stuck in it. Just don't stay in that one spot. Start pushing the boundaries of it. You know, in this case, this dude here, he's got to start looking around, maybe even looking up. Okay, he's an astronomer, look up. If you're a geologist, look down, whatever. Anyways, so the cognitive bias ain't bad. Now you got two problems that we've been talking about in this video. And the first is identifying what is the unknown. And I use things like DOTI to do that. Diversity of thought and imagination. And it's easier for me than most people, or lots of people, because I have a pretty good imagination as a result of my random thinking processes in my head. I don't think linearly. I don't think even laterally, for that matter. It's random, totally random. And that gives me an advantage in terms of imagination. The second thing is I have a great wealth of experience in business world, in the sporting community, in science, and I use all of those different perspectives to help me see a problem differently. Certainly not as good as what Albert Einstein did, no doubt about that. The guy had incredible thought experiments. But the bottom line is it gives me an advantage over many. Okay, so that's one aspect. And that helps me to identify the knowledge gap, what it is I'm looking for that I don't understand. Okay, and then the next thing is to get over the knowledge gap. You got to start generating ways to do that, and it's a methodology. It's so I try to build serendipity into all of my observations because serendipity is a natural method for finding new discoveries. Obviously, you find something serendipitously. That's the answer. So that's one way. There are others. You can do the shotgun approach. Just do lots of different experiments and then see what sticks. Find something that's interesting. Do that too. So there's the story. So you got these two problems, and really in the end, and I want to make this very clear. You start from your bias, and it's a journey to the rest of it. Okay? And really in science, what we should enjoy is the journey. And so I say this to all of you. Just go out and enjoy your journey. Whatever you're studying, just go out and enjoy it. Find joy in whatever you're doing. So don't worry about biases. Just worry about doing cool things.
The JIRA Foundation will produce more videos like this. Please like, share, or subscribe if you enjoyed this video.